Okay. Now, so that's the badminton things. Okay. So why? Okay. It's when the instance that when your object is going up, right? Now the first idea is to survive all these concepts. We've got to destroy some concept we have. We always think about the time taken to reach a certain height versus the time taken to reach it. Compare the same things. Without air resistance versus with air resistance. But no, we shouldn't think that way. Because the maximum height you got to reach with air resistance and without air resistance is different.
Yeah.
Okay? So this is why, right? This is why how do you define the top instance? The top or parabolic path is when the vertical component is retarded until 0. The horizontal component, 2 case all don't change. Assume that. Let's assume that. Okay. So the idea is that if all hit with the same speed, same angle up. So how do I reach the top? It depends on how fast my vertical speed goes 0. It's not about reach on the height because of two height difference. Okay. So the faster you reach the vertical velocity is 0, the faster you reach the top.
You trying to say that if you
hit without air resistance, hit with air resistance. Yeah.
Maybe if you hit it slower, right?
Let's say hit the same. Right?
How
do you define the maximum point? The maximum point.
How your initial speed becomes 0.
No, the vertical components of a speed at that instant goes 0. That is the turning point, right?
Yeah.
After that, you got to drop down, right? So the idea is that if they all hit with the same initial speed, so they all have the same initial speed. So who can have my vertical component consume the fastest to 0 faster? Okay, let's say 20 drop to 0, 20 drop to 0. Okay, but who can drop to 0 faster earlier? The time taken will be shorter. Because definition of the top point is when your vertical component is 0.
Without air resistance, will be faster.
Without air resistance or with air resistance, anyway, where do you define the top instant? The top instant when your vertical component of vertical velocity goes 0, or vertical speed got no more speed. Vertically is not moving up anymore.
Point,
sorry?
Maximum point.
Maximum point, you're right. So when is maximum point occur? Where vertical speed is 0.
Yeah.
Okay? So how can your maximum speed equal to 0? Well, how can your speed equal to 0? I must consume away my speed. Because initially you have all the same vertical speed.
Yeah.
Got it? So the idea is that if you have air resistance when you're going up, right, the drag force and mg are all pulling you down. But without air resistance, you only have mg, no drag force. Okay? So with drag force, it help you to reach, have a greater downward acceleration, which is a retardation for upward motions.
So you will reach the maximum point faster.
This is why if you hit one with air resistance, one with air resistance, same angle, same speed, right? The one with air resistance will reach its maximum faster. Okay? Okay? Because that's the definition of its own maximum point. Okay? Now, the point is that when you come down the time, right, how to define bad coming down? Now, coming down is a different case, okay? Because you don't need any maximum anymore. So coming down is actually there is a vertical distance you have to travel. A vertical distance you have to travel. So the faster you travel there, the shorter time is taken, right?
Yeah.
So in order for you to have faster traveling, you need a higher speed. But for the dropping down motion, you start your speed with 0.
Yeah, then.
So the idea is that you can accelerate faster, you can have a greater speed for most of the time, then that means you can drop down faster to travel this distance. Now, so coming down is a different story, okay? So therefore, with air resistance, you can see this case. With the air resistance, it's like that. Now, with the air resistance, right, downward is mg. So you have 9.81. But with air resistance, right, you destroy your mg a little bit, by a little bit, okay?
It will be slower.
Yeah, so it will be slower, okay? So it will be slower because the acceleration will not be mg anymore. Okay, the drag force helps to get rid of the some mg's accelerations. So therefore, the speed will not change much. We will say that if it's initially fast, it will not change much. It's a good case. But in this case, is that in the beginning it's 0. It will not change much. It's still very slow. Okay, so therefore, coming down falling objects, right, the time taken is more. than the without air resistance. The rising object one, it is the time taken to reach its maximum is faster than without air resistance. For the thing without air resistance, it is symmetrical. The time up versus the time down is the same. Conserve energy, right?
Yeah.
So you see, one guy is faster than that, and another guy is slower than that. Where these two are supposed to be the same, you know there is a lot of proof saying that the time taken for it to come down is a lot slower than the time taken to go up.
Yeah, but overall, it seems like when with air resistance, when you go up a bit faster, when go down a bit slower, right?
Yes.
And when without air resistance,
Symmetrical.
same.
Yeah.
So overall, from your initial one to the end, to the when the final one, right, which one will be faster?
If you sum it up, right, I never do these calculations. You may not know. Can be faster, can be slower. It depends on how tall it goes. Okay. Generally, I believe with air resistance, it will be slower. Yeah. But I never prove it. Okay, so just like that. Okay, so that's all I want to tell you for the whole kinematic here. I think I covered all already.
Yeah.
Okay, let's start to practice a few to see whether you can do it. Okay, now this questions is a very typical questions. Okay, if you use the kinematic wave for boxes, okay, it will be very horrible, but you still can do because you have 4 columns. Okay.
How does it need 4 columns?
Otherwise, you use conserve energy. It's very simple.
Okay.
Okay, vertical, horizontal don't change. Only play around with the components, right? And you know that this is symmetrical. Okay, so drop how much. It's very easy to be produced. Okay. Now, you have 4 instances. You have 4 columns because you have 2 instances. Okay. When I have you have a U, you have a V, you're telling from where to where. Okay, so in this case, then let's do it in a very problematic way. Eh? S-U-V-A-T. Okay, the case 1 means from here to here. Okay,
Yeah.
case 2 means from here to here. We don't do from here to here. Okay, this is even worse because the initial vertical component is 0 here, but the vertical component is not 0 here. So horizontal, vertical, positive, 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 positive. This is the 20 meter one. This is the 50 meter one. Okay, so horizontal here. So the time for this is T1. The time for this is T2. Okay, fill in everything. So horizontal 25, vertical. Okay, so vertical distance that you move is 5 mm. So 5 times 10 to the power.
-3.
Okay, so horizontal this is 50, and vertical is actually your answer, if I'm not wrong. Okay, the new distance below P, right? Okay, good. Okay, so initial speed horizontal is don't know. Okay, now horizontal is don't know, and vertical is 0. Vertical is 0. Initial, right? Initial from at this instant. Okay.
Yeah.
So V, this V, right? Horizontal V is no acceleration first 0, 0. So meaningless. And this is 9.81. So I take our positive, so minus 9.81 minus 9.81. Okay. I think I don't know. So V, and V, 2. Okay. V, 1. Okay. Okay. Now this is my answer. Okay. In order for me to get the answer, I need 4 variables here. So of course I will choose 1 and 2 and 3 and 4. Because why I don't know this, I don't want to bother this. This can borrow from here. Okay. So what is the formula here? Is the without V. So S equal to UT plus half AT squared, right?
Yeah.
Okay. So I need a T. Okay. So T here. So this is a speed, distance, time, right? Okay. So in order for me to calculate this, I need to find. Okay. This is speed equal to distance over time. So to find time, I need the speed. Now this speed can borrow from here. because they are same initial speed, right? So now for me to find the speed here, I need speed with this over time. Okay, so the idea is that I need to find t1. Okay, so in order to find t1, borrow from here, which is 1, 2, 3, 4, bingo. Okay. Okay. So we use s squared plus half a square, find the t here, substitute here. You can find the ux here, you find the ux here, you can find the t2 here, you find t2 here. This way you can find the answer. But that's the long way to do.
It's like, for example, the second column you cannot do from this point because is it more troublesome, right? If you
No, you can't. Yeah, because the initial you don't know how much. The initial of this instant is the final of that instant, which is very problematic. And vertical is not 0. Okay, so it will be very problematic. Okay, so it still can work. Okay, always in tabulations. Okay. But consider now. I think now whenever the Cambridge says a student means it's wrong.
really?
Yeah, teacher means correct. Student means wrong mostly. Okay. What else? Why should I go? Here's the method. Principle of quantum and mechanical energy. Gain in gravitational potential energy equal loss in kinetic energy. Half mgy here. It's equal to half mu squared. U is here. 25. They substitute 25. 25 because substitute 5, right?
Yeah.
So if that's the case, right, you're meaning that at this instant, all the kinetic energy here become all the potential energy here, right? But this one still have kinetic energy. Got it? Okay. But if they illegally put it 5 sine 60, numerically be correct. Okay. So this is a wrong thing. This is gain in gravitational potential energy, loss in kinetic energy is correct, but the loss in kinetic energy is half mu squared here minus away the half mv squared. This is the horizontal. I still have speed.
But I thought you must calculate the original, like for example, like here is the mgh here.
Gain what?
Mgh. That means you got the potential energy here. Then you compare that means this point and this point.
So you say mg60 and mg60 plus y, is it? Yeah, can, okay. But mg60 at the left hand side, mg60 plus y at the right hand side, the mg is distributable to mg60 and mgy, right? So cancel mg60, you still only get mgy. The gain amount equal to how much you lost for the kinetic energy. Okay? They're not considered total energy at this point equal to total energy at this point. They're thinking about the gain or loss, or the supplier, the consumer of energy is the same as what you get as extra of energy here. Okay? You always have two ways of thinking, consume energy. Initial final moment, or total gain or total loss. To me, I would say total supplier to total consumer.
So the statement because they never include
No, the idea is this is not equal to this.
Must include now negative half mv squared the speed here.
Yeah, you're right. Okay, that will be correct. Okay, okay, let's discuss questions you know about it. Okay, you want to try some real questions. Assignment, right? Oh, cool.
Yeah.
If you can handle assignment, does it mean that you know this chapter?
My homework for this one, this is very long ago.
Have you done it?
Yeah, this one I think not long I copy from people.
Copy from before. Can okay, I want to means you never really do it, okay? Okay, try, okay, let's try all this method, okay? A dive bomber diving at angle 53 with a vertical. So, what must you do? Yeah, scribble, okay? Horizontal, vertical, right?
Diving.
No, okay, we have a dive bomber, just draw a circle whatsoever, okay? And then what happened? There's a vertical, right? Draw vertical, okay? You have to draw a line vertical. Don't care about what it means, okay? There's a vertical, okay? So it's diving at 53 degrees with the vertical. Okay, so okay, just draw something.
Something like this.
Okay, good. Yep, give me an arrow. Okay, it's diving this, right? So what is this vector means? This vector actually is
initial speed.
Yeah, it's the velocity, right? Because it's where it is at that instant. So you label it as u. Okay, initial speed u is u, right?
Yeah.
Okay, SUVAT. Okay. Okay. So in order not to confuse this with a v, okay, try to use a small u. Okay. Okay, release a bomb at the amplitude of 730 meter from the ground. So of course, the airplane will left, but the diving bomb will follow in this way, right? Okay.
So that means the bone like drop vertically down.
Yeah. Now we gotta know these things. Okay. When I throw an object, okay, this object before this object leaves my hand, it is with my hand. Okay. Cheap. Okay. So what actually it is that the starting of any motions, a new motion, is always the same instant of the previous motions in all physics. Okay, that means the starting of this object right it leave my hand is just the last. It should be the same instant. All the velocity, acceleration, whatsoever will be the same instant as if it is just before it left my hand. So if I carry my object in this way, my hand also travel this way.
Yeah.
When the instant it leave my hand, that same instant right there, also same direction and same velocity, same displacement, same acceleration. But then when I leave the object leave my hand at the time, my hand can go away. This object carry on. Okay. So the first instant is always copy the last instant.
So for the bone to drop deflate, that means the plane must be going down like that.
It got to be same directions. And once it release the bomb, the plane can fly away, but the bomb will keep free fall in that directions. Okay. So like that. Good. So now you only consider the bomb, right? Don't care about the plane, right?
Yeah.
Okay. So just draw a path that will just hit the foremost properties. How does it look like? Yep. Okay. Whatever. Okay. Good enough. Okay. Good. Now, so what other information you have? We still have a time equal to 5 here.
Yes,
So this is horizontal vertical. This is horizontal vertical. 2 columns, right? 2 columns, right?
This is for the.
It's 2 dimensions. Not just one line front back or just up down. It is. You have a horizontal range and such things. Okay.
The time for both vertical horizontal is the same.
Yeah.
Right?
Yeah. Horizontal way you take positive. Draw an arrow, okay? Follow what I did. Okay, follow what I did. Okay, you always draw an arrow tells where is the positive, where is the positive. Okay, always tell you where is positive. Okay, follow. Yep, vertical. What do you think in this case? No good. You can do it, but no good.
Because all values are negative.
No. Where is the initial directions of your object?
No.
It's moving down, so you take downward is positive. It's always easier. Okay, to use the initial. Okay. Okay, so check, is all the number correct?
Haven't filled in all yet.
Now, is this positive 730 or negative? Positive or negative? So this is the initial point. This is the final point. You draw a vertical. This is a vertical component. You draw a vertical displacement vector. The arrow points down or up?
Down. So
Down.
positive.
Yep. So this is positive. You got to think this way. You're very careful. Very careful. 9.1 positive.
Yeah.
Yeah, because it's down, right? Good. Okay. Now, acceleration is 0, so you don't really care about the v. Okay. V and u is the same thing. Okay. Good. Now, so think about this. What is this and what's this?
For vertical is.
No, don't say vertical. You okay? Yeah. Okay. Opposite and adjacent. Okay. What's this?
Cos 53.
Wrong. Sine. Remember. Okay, we don't do horizontal vertical. We do opposite and adjacent. Opposite to adjacent. If you use this angle, this is the opposite. Luckily your teacher tricks you, okay? So that you will be alert in this. So this is u sine phi 3, okay? Yep, good. Okay, so that's the u cos phi 3.
So vertical is starting speed for vertical is u cos 53. This is okay.
Okay, good.
Then the horizontal, the displacement is also same.
Just put as horizontal. This is the as horizontal, right? No, vertical, you just say v vertical. Okay, no harm, just leave it as unknown. So what do you want?
You want the speed of the bomber.
Okay, wait, what is this? What is this, huh?
Oh yeah, you. So it's u.
Yeah. They want to find u, right?
Mm.
Okay, now u, this unknown is at where? At both sides. Okay, so choose both. Which one you choose? In here you only have one equation, which is speed distance over time, right?
Yeah.
So there's no way you can know the distance.
So you choose.
Yep, so
So you got.
Mhm.
Distance.
So what do you need to choose?
50 plus 50
Yep. Okay, substitute in.
Okay.
Good.
Then from here you get the u, the initial.
You're right.
Then this u is also from here you calculate the u, then the u is the
Where?
speed of the bomber.
You're right. Is it? This is u, right?
Yeah.
So this u is the instance that the bomb's initial speed, right?
Yeah, this
Which should be the instance that the dive bomber dropped the bomb, the instant, right?
so but then should be the same speed.
Yep. Okay. Okay, so bring over, divide all this thing, use your calculator to solve whatever it is. Okay, so next part, how far did the bomb travel horizontally? Do it here, okay?
Huh? Sorry?
Try to be messy, okay? Yeah, we are all physics and math students, so try to be very messy. How far did the bomb travel according to this fight? So what does it ask?
They're asking for this one.
Mm-hmm.
So you got the u already.
Yeah.
You can use like
Mm-hmm. What formula?
acceleration equals 0, so equals
Mm-hmm. So what do you have?
so equals distance of time.
Yeah.
Then the speed you sub the u inside.
You're right.
the
Ah,
distance.
okay.
Yeah.
Okay, so last instant. What were the horizontal vertical components of velocity just before it's striking the ground?
Striking the
Where's the instance? For this picture.
Here.
Here, yeah, good.
Then
Okay.
so draw another triangle.
No need. Okay. So what are you all draw everything here already? So which are the two things they want? They want horizontal, vertical.
Fine. So you can define this one. So you. But
Yeah,
it's, but it's
yeah.
not, you got all like you got all already. You just
Yeah.
now pick one.
And you pick 4. Okay.
So just
The best practice is not to pick the one that you derive from just now, in case you have any calculation mistake.
you also have you already. Then v square.
equal to u squared plus 2as, right?
Yeah. Then u equal to
Yeah, okay. So just use the u if you want, otherwise you choose this 4. Because in case just now you calculated u wrong, you just choose this 4. Okay, so no u which is not allowed. Okay, so you better choose your combinations. So you're correct, okay? No u is not allowed. Okay, so so vertical final component will be this answer, so that's the answer, right? So how about horizontal?
horizontal component.
So where is it?
Velocity down
The kowtow, right? The
Yeah.
cross, right? Okay, so what is this? Why do you need to do that? Why do you put a cross there? Because acceleration equals 0. So what does that mean?
The final speed and initial speed is
Same.
the same.
So answer is
u sine infinity.
you're right. Okay, substitute right u into. Done. Okay. Yeah. Question 2. Okay, the stone is thrown.
From the ground upwards. Horizontal. Sketch the variation with time.
Upward.
So we throw it outward. Kinetic energy.
Wow, this is very cheap.
Depends on the V.
Okay, fine.
Every sense negligible. The V will decrease. Increase. So it should be something like that.
This VT graph is it?
No, it's a energy time.
So, how do you think about it?
I
Energy
think
time.
the thing should be a U shape.
U shape.
Yeah.
This is energy, right?
So at the maximum point, right, the kinetic energy equals to 0.
Okay, energy equals 0, you sure?
Because your V at the maximum point is 0.
You sure? You're right, but are you sure?
Yeah, sure.
Sure. The object is stationary at the top,
Yeah.
which is not moving left, right also.
Yeah.
You sure?
Yeah.
So it hang in the mid-air.
For temporary movement. Yeah.
You sure?
Yeah.
Vertically, it is momentary at rest. Horizontally, the speed got change or not?
So no change.
Horizontal no change, right?
Yeah, no change.
So there is a speed or not?
Horizontal speed.
Yeah. So is there a kinetic energy?
Yeah.
So can you draw it 0? No, right? Good. What can you do? Counter that.
That means not so the type is 0 at all. That means just something like that. Very.
It makes sense, right?
Yeah.
So you cannot touch 0, okay? And secondly, it is symmetrical.
Yeah, because it's no air resistance.
No air resistance.
It's
Yep,
air resistance.
yep, you're right. Okay, and secondly, it's constant energy, right? Get energy, give potential energy. Can you get back the same amount of energy?
Yeah.
Thirdly, Yep, good, like that. Okay, so do you need to label any point?
Like here is
This is good options. Okay.
here is
EK. Gravitational potential energy of the stone label this as EP. So how about EP?
EP.
So write EK there.
Independent on H. So we go higher. So it should be like in. When they say a stone is thrown from the ground upwards, you still possess some MGH, right? Because you cannot throw the stone from the
Now
ground.
wait, you read the question carefully. Okay, say 50 meters per second at 60 degrees. You didn't throw vertical. You didn't throw vertical up. You throw 60 degrees. Okay, that's what it is. So initial, it's up to you, but we always assume that unless it's status, otherwise it says that the ground level will say zero potential energy, right? So the whole process from here to here to here. Okay? Good.
What's the thing that baffles me? Because like, how to say, the stone throw from ground, but like stone can't be thrown from ground. I should not have like holding it.
Correct. Yeah. So roughly, like ideally, if you can be thrown from ground, okay? The stone don't know how to project himself up here. On the same axis means it's in one diagram. Yeah, they want everything. Yep, so you got to combine that.
Yeah, well, okay.
They want to see how you do the scaling and thinking. Okay, hold this first, okay? Do the third part. Total mechanical energy. Mechanical? Why is it mechanical?
Is it mechanical? You add up both together.
Total energy, I think, yeah. Mechanical. What's so mechanical about it? Oh, mechanic, okay? Because we're in mechanic, it's fine. Total energy, okay?
Total mechanical energy, yes, it is. Straight line.
It's a straight line, the shape is all correct. Okay? But can my total energy,
Oh.
yeah,
Let me throw it down here. Yeah, wait.
thing, yep. Which point can tells you the correct value of the total energy you have?
Total energy. Oh, should be the max energy for all. That means
For what?
for the kinetic and potential effect. Here is all the max. This is the line.
Okay, you're closer, but are you being careful? Are you being careful enough? Now, a few things here, okay, now all your point is going up here. Okay, it doesn't start with 0, right? It starts with 0, right? So where in front? Come on, draw nicely, okay? You don't start here, right? This is the axis.
Oh, again, sorry.
What are you doing here? You're doing very suka things, eh?
Oh, let me throw it.
Draw nicely, okay? Draw nicely first, then we can talk. If you draw nicely also bo chap, then very hard to talk. Draw the guideline first, okay, if you want.
It's something like that, but it's...
Draw the horizontal guideline first if you want. In here. Yeah.
Which is PT.
Okay, done. Okay, more or less that. Now, if you're an examiner, you want to give each mark on each features, okay, so that you see how many you're correct, right?
Yeah.
So tell me how many features are there you would like to have, if you were the examiner.
For each respective graph or the whole...
On this graph, right? Let's say I have these things. I say, okay, the principal come and ask, these questions. You say how many mark is there, and each mark are located where.
Actually, it depends. This type of question, if there's you beforehand is like, if have you work out already, you can just put it on the labels there.
Yeah. But if you want to check whether your graph is correct to the answer, so how many different features are there must I check? So that I can still give you some mark if you sum along. 6, okay? So where are the 6 features? Whether you draw it correctly, I'm going to check this point, whether this point is correct, this point is correct, this point is correct. Correct 1 mark, correct 1 mark, correct 1 mark, correct 1 mark. How many features are there?
4, I think 4 for each graph.
Okay, fine. Okay, point me where the features that you think is worth the mark.
One is like the axis.
No, this one doesn't worth the mark. Okay, axis fine. Okay, 1 mark. Okay.
Then plus your
Yep.
initial part plus your...
No points.
Oh, your initial point.
Okay, this is 1 point. Good. This point will give you 1 mark if you're correct. And this is 1 point if you're correct. This is 1 point. Okay, what else?
3 plus the labeling.
No. How can you keep it so one? These 3, you're biased, right? Why you only care about this line?
Oh, for this whole figure.
Yeah, of course. What the whole question is
so
what?
It's here.
Yep, good. It's 1 point. Yep.
Here.
Here is 1 point. Yep.
Here.
It's 1 point. Okay. Now,
all these really like.
now this is also
Yeah.
in 3 points. Now, so the idea is that there are 6 points, totally 9 features there, because this one is redundant for this line is correct. It's correct for this or this. Okay, 1 by 1.
Yeah.
Is it correct here? Is your potential energy 0 here?
Yeah.
Okay, is your kinetic energy maximum at this point?
This not kinetic.
Kinetic, right? Correct, right? Is the total energy equal to the sum of kinetic energy plus the potential energy at this point? Yes or no?
Yeah.
Good. So you have 1 tick, 2 tick, and 3 ticks. Okay? Now take a look at this. Is your minimum kinetic and energy at this point correct?
Yeah.
Why? Reason?
It's like it's somewhat a bit stationary. Only the horizontal velocity is present. The vertical.
So this is why you should have some values still, right?
Yeah.
Good. Very good. Should you have maximum? Should you have a maximum potential energy here?
Yeah, because it's the
Yep, it's a maximum height, right? Good. Is the total energy equal to sum of this plus this in this point?
Yeah.
You sure?
What do you mean by the sum? That means you...
Okay, let's say this point, the potential energy here is y equal to 10. Okay? Let's say this is y equal to 2. Total energy equal to what? How much?
12.
12. So how can it still be the same point? Okay? Here, correct. So how to make it correct?
That means a slight increase here.
You're right. But if you increase this, what happened here? what happened here? This cannot be a curve, it's got to be a straight line, no?
So the thing push up also.
You're right. Something else got to be pushed up. Try, okay? Be very careful. Now, in physics, right, we don't do much by thinking. We do much by doing whatever we can do. In maths and physics also, we do whatever we can do. Okay? So, what can you do? Axis you can do. Okay? Okay. This point, can it be non-zero? Potential energy here. The height. Cannot, so it got to be this point.
Yeah.
Okay? Can it be is it a maximum?
Yeah.
It's a maximum. Okay? Is it a minimum?
Yeah.
Yes, right? So this curve fixed this way. Make sense?
Yeah.
Good. Okay? And secondly, this point, you need to have some height. Make sense? Okay. And then the third one is that the total energy here got to be a bit higher than this point. Make sense? Because you need this plus this, right? Now, so what else can you do? You may not be able to do, don't know what it is, but can you do this first?
Can do, maybe you draw a line, then you form.
Yeah, good, okay. So, do what you can do.
Then,
Okay.
from here, you just start from here, connect to here.
This is what you mean? Think, at this point, the total energy is equal to that value plus this value.
Yeah.
So it is 0, so that one got to be?
That's the answer.
You're right. This is the answer. Okay? Okay, don't sugar, okay? Think. Anyway, hit it once, okay? Next time you won't get it. Okay? When you have totally 0, your total energy, kinetic energy, potential energy, most of the time will be a very general graph like that. Okay? When you have kinetic energy not 0, most of the time you will shift the total energy and the kinetic energy up. Okay? So it's that. Got it? Anyway, it's not very wrong, okay? But pretty perfect. Okay, last one. It's the last one. Oh no, last one.
So more variation. Height.
Sketch a variation with height.
Oh, this variation.
Okay, the edge is don't label as KE. It's also KE, PE, and ET, right? So do what we can. Can we say that ET is always the same number for all height? Total energy leh.
Total energy for all. Actually, all total energy is the same.
Yeah, no, you sum of both, right?
Yes.
So for all height, it is like that, okay? Yeah.
Then kinetic energy of the kinetic energy
The kinetic energy is cheap. Take potential energy first.
of potential.
Potential is always easier. Potential height, right? Height.
It's not increasing. But this case, right? You want to do the maximum point, it's not increasing, or just do the maximum point after that.
No, they got nothing to do with the point because that's the time. That's the time. It means that what is the meter to the right? So the right means is have a higher height, right?
Yeah.
So it's just with that idea, when something throw up, when the height is higher, what happened to your potential energy?
Higher also.
Higher also. Okay, it's got nothing to do with the process. Okay, don't imagine the process because it's not. We always have the concept of time. Whatever you can imagine is always with time. Okay. Now this is not about what we imagine. It's not the process.
Yeah.
Okay. So it is just height. Okay. So think about formulas. So is mgh proportional to h or not?
Yeah. Just.
No h, no mgh, right?
Yeah. So just
So-
increase. So it's like a straight
Yeah, right. Good, good, good.
line. So just.
Shorter one. Okay. Don't care about the rest. Okay, so tell me what is the meaning of this point?
This point is whereby all the potential energy is the energy. That means the ball is not moving at all. We just.
Wait. The ball is always moving horizontally because 60-degree horizontal throw, right? It's always moving. So what is the meaning of this? It's a maximum. What you have?
Oh, this is a maximum height whereby.
Yeah. So the top one. Okay. Okay. So it's not a progress. So you don't map to what you see and what you imagine. Okay. Whatever is not time. So, if that's the case, right? This is total energy, right? This is potential energy, right? So what's kinetic energy? Right?
Just the inverse of this like that. Because you do this thing.
You're right. Total energy equal to this plus that one. Okay. What else can you choose? So I don't know whether it's correct or not, but it seems like that.
Yeah.
You're correct. Okay. Just like that. Okay.
Okay.
Great. Okay. Done. Last one.
What about me?
Yup. American football kicker was whatever crap get initial speed that with within what two elevations angle must he kick the ball to score a field goal from a point 50 meter in front of goal post. Horizontal bar is 3.44 meter above the ground. So I think it kicked from the ground. The ball must pass above the horizontal bar. So, yep, this is good, okay, but don't do that, okay, just say this is 3.44. You have to kick anywhere higher than that. The speed is fixed. Theta is open. 50 meter, 3.44. I think all the info is here already. So
Tabulate, right?
yep, tabulate out. So the critical moment is when it just hit the 3.44 meter. Okay, so we do the critical moment.
S equals to this range.
What is the range then? Horizontally. Good.
Initial speed for vehicle just u horizontal is whole thing is opposite. This is opposite with sine
Good.
cos, so horizontal
So it's 25, right?
5 theta.
Oh, okay. Yeah, good.
This vertical is 3.4.
Good.
So initial speed is Yeah, my solution is 95.1. This
Good.
time you will also be
Yep, good, great. So they want to find theta. Cool. How do you find theta? Start from anywhere. Doesn't matter.
because the distance over time you get those. Or you can do simultaneous.
You can say in that way, but you need not to. You can, but we need not to. Okay? So start with anyone. Okay? The idea is that both way can. Start with what? Start from where? Start from here now. Start from here, you need to find what? Theta, right? You need to find theta, you need to find what?
The u. You want to find the u, you get distance over time.
Yeah. So what do you need?
Time.
Time. So time borrow from here, right?
Yeah.
If you borrow from here, how do you find it? You need 4 things, right?
1,
2, 3, 4.
Yeah.
Which 4? Can't see which 4. Good. Yeah. Okay. So find the time first from there. Wow, this is tough. I think this way easier. Okay. Yeah. Then you can substitute the t inside. See. Your GC is the Casio or the TI?
TI.
Great. Okay, you must use that one because the Casio one I till today I can't master it.
A lot of functions are
Too many zoom in and zoom out, zoom in and zoom out. Too
I
few
don't know how to
buttons.
use the calculator, a lot of stuff.
I teach you, don't worry. Okay. Just substitute inside first. Okay. Make a monstrous equations. Doesn't matter.
3.44 equals to
Mm-hmm.
maybe tangent already.
1 over secant square. 1 over cosine square. Cosine square is secant. So tangent square is secant square. Minus 9.1 divided by 2. Wow. Okay. Time 50 square. Well, 50 divided by 25, is it? Time 2. 50 divided by 25, right? 4. Time 4. 4 secant square theta. Okay. You should GC. Find answer. Take out your GC. I teach you how to find answer. Okay, don't stop after this lesson. Okay, I want you to handle the kinematic once and for all. We don't come back. Okay, try not to come back. Okay, now for GC, right? Actually, you have a 5 mode. The first mode is this kind of calculation mode, and you can key anything you want. This is the first mode. Second mode is the graph mode. Okay, all these kind of things. The graph mode. Okay, the third mode, right, is the matrix mode.
Second function.
Yep. The third mode is called matrix mode, which is here. Okay, second.